this is actually kind of hard to explain. This is like my third take now because like it's kind of weird to think about. But so we're talking about the mole, and the mole's kind of an important idea because you're working with junk in the lab, and it's you can't just say give me one atom of carbon, give me two atoms of oxygen, and we'll make a CO2 because that's super tiny. It's like you can't really work with just these super duper 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 tiny atoms. You can't even see them. You can barely register they exist. So how are you gonna get your hands? How are you gonna get big fat hands on these atoms? So you got to work with a lot of atoms. You got to work with a big ass clump of atoms, something you can actually physically see and touch and manipulate. And so that's where the mole comes in. The mole is essentially a huge group of something. Like we got a dozen. A dozen is 12 of something. So give me a dozen donuts. Give me 12 donuts. Give me a dozen butts. Give me 12 butts. A pear is two of something, right? Give me a pair of CDs. Give me two CDs. And then you got a ream. A ream is 500 or something. I mean, you really only use it like a ream of paper. Just give me a stack of paper, 500 pieces. So a mole is 6.02 times 10 to the 23rd or something, which is 6 and 23 zeros, which is a lot of zeros. It's a real big number. It's called Avogadro's number. Some dude named Avogadro figured it out. So you hear that a lot. But these things are important. So like, let's say you have carbon. You got carbon, and you want to kind of move around between atoms, moles, and grams. Mass, and then moles, and then individual atoms. Your teacher talks something about molar mass, right? And that is a direct like conversion of grams to moles. So if you want to convert from moles to grams, you use molar mass. So like let's say carbon, if you look on the periodic table, you see the weight of the thing. That pretty much exactly works out. You just say that's grams. So if it says 12 grams on the table, it says 12 grams per mole. So carbon weighs 12 grams for every mole you got. There's nothing really to it. And then if you want to go from moles to atoms, that's where you use this number. So you just use 6.02 times 10 to the 23rd. Whoop. And then so there's 6.02 times 10 to the 23rd atoms in one mole of something. Those are the two things you'll be using a lot for these problems. So like the first one was what was it? It was like the very first one you had was the molar mass of TNT, and so you did it right. Like it gives you the chemical formula C7H5N3O6, and you just look at the periodic table, look at their weights, and then multiply and add as necessary, right? So carbon weighs 12 times 7 because there's 7 of them, and then H is 1, weighs 1, and there's 5 of them, and then you got nitrogen. So you got nitrogen is 14 times 3 of them, and we do oxygen, weighs 16 times 6 of them, and you add that all up, and it gives you around 227 grams per mole, and that's the molar mass of TNT. That's pretty straightforward. It doesn't get any harder than that. Like if you need to figure out the molar mass of something, you just look up the elements, how much they weigh, and add them all up together. And then you had the second one, which was how much does 5 moles of TNT weigh? And anytime you do a conversion, or anytime I do a conversion, I always try to like start with an actual number, not a conversion. So like in that problem, the number they give us is 5 moles. So like that's why I start with 5 mole, and then I need to convert to grams. And so to convert to grams, I use my boy the molar mass, because it's grams to mole. It's got both of them in here. So we use the molar mass for TNT, which you just figured it out. And you make sure you line up your units. That way you're not flipping it wrong. So 227 grams per mole. And so, these cancel. And there's just 5 times this, and I think it was like 1135. Right around there. Somewhere around there, right? So fine and dandy like sour candy. And then you got like number 3, was if you got 1532 grams, how many moles is that? Well, it's just the same thing, but in reverse. 1532 grams is the number they gave us. Wah, 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 wah. So then we're going to use the same molar mass, because we're just going from grams to moles, moles to grams. But this time, we're flipping it, because we got to line up them units. Whamp, whamp. And then you get moles. And so it just ends up being, divided by. And that's, I don't even know. Let me punch that into the calculator here. 1532 divided by 2227. Apparently it's 6.75 moles. So I mean it's just you're using molar mass to do basic conversions. You're just making sure your units line up is the most important part. But if you need to go from grams to moles, and that's going to come up a lot, you just use the molar mass, work that molar mass. So 6.02 times 10 to the 23rd. That's an important number. Don't forget it. And then we got molar mass, which is grams to mole. These are important. So then, like, they start giving you problems with dealing with molecules and stuff. So like whenever you see the word atoms, like they want you to figure out how many atoms there are. They want you to figure out how many molecules there are. Sometimes they'll throw you a curveball and they'll give you formula units. Wah, 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 wah. These are all clues that telling you, hey, you gotta use that Avogadro's number. You gotta use that number, because that is the number that makes you go from moles to any one of these suckers. I have to cuss. I gotta stop cussing so much. That number, that AV, baby, that AVG, that's gonna take you between these two. So like number D or whatever, it's like how many moles of TNT are in 3.01 times 10 to the 22 molecules of TNT. Well, first of all, your number is 3.01. This is that D times 10 to the 22 molecules. I'm just gonna write MC because I don't want to write molecules. So we're trying to convert this to moles, but we gotta use that AVG. We gotta use that Avogadro's. We gotta use that number, and the way you use it, it's 6.02 times 10 to the 23 of whatever you're looking for. In this case, of molecules in 1 mole. And so you punch that in the calculator. I don't want to do it. Something something. It's 0.0 something something something. I don't want to do it. But yeah, I mean that's pretty much all you're doing. E is what is the mass of 3.01 times 10 to the 22 molecules of TNT. So it's the same problem. You're just going one step further. So like you're starting out, it's pretty much the same. 10 to the 22 molecules of TNT, and then you're turning that into moles. So you use Avogadro's, and 10 to the 23rd molecules for mole. And then you can go to grams because you got that molar mass. So you got 227 grams per mole. Remember, you figured this out earlier. Don't fuck it up. You figured this one out earlier. And this comes out to some number. I don't know. It's a number, So that's pretty much how it is. Now they're trying to throw you some curveballs. So like now they're saying how many atoms. I want atoms. Give me atoms of C. I only want the C's when we're talking about the TNTs. Well, you're saying like what? How are you just gonna pick out the C's? You only pick out the green M&Ms when you're eating the bag of M&Ms? No, that's dumb. You eat all of them. No, life is dumb. So you gotta single them out, and it's not that hard. It's not hard at all. It's just like common sense. So like look, homie. Check this out. Check this shit out. So we got our 3.01 times 10 to 22 MCs, molecules of TNT, right? You can even write molecules of TNT if you really wanna. So think about it this way. One TNT is C7. Oh, geez, I wrote this down here. C7H5N3O6, right? So 1 mole of TNT contains all of these. And what you're really saying is that you contain 1 mole of the entire thing contains 7 moles of this, 5 moles of this, 3 moles of this, and 6 moles of that. Make 1 mole of the entire thing. Which I don't know if that really comes across. If you don't really get that, then holla at me, and I might be able to explain a little bit deeper. But essentially, you know, it's the sum of its parts. So when we're saying how many C's are in TNT, well, you just look at the numbers, son. So you can say that 1 molecule of no. Forget everything I just said. Forget everything I just said. I'll get to that in a second. I'm making this line super long now. First, we're going to convert this to Avogadros. 23 MCs, molecules, to moles. Moles of TNT, baby. Moles of TNT. Right? And now you're ready for it. So in 1 mole of TNT, baby, 1 mole of TNT, how many moles of C do you have? Well, you look right here. How many moles of C? How many C's do you got in that TNT? You got 7, son. You got 7. You got 7 moles of C, and bam, is that easy? Is that easy? I don't know. Maybe there's infinity. It's not infinity. It's not. That was pretty cool. Look at this. It's like an animal. Womp. 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 Okay, it's not an animal anymore. Oh god. It's kind of like a bug. Or it's kind of like a dog, actually. Anyways, I mean, that's basically the idea. The last one, 5 moles of T, how many moles of C? I mean, it's the basic idea. You're converting from moles to molecules to atoms and all this junk. You're just going back and forth between these things. I don't know. If this doesn't help at all, let me know. And I'll do it in a way that's not so dumb.